Welcome back, everyone, for a much more reduced audience suddenly, but I hope we get a bit more participation. I'm going to do, no problem, please, welcome, no problem at all. I'm going to do the big risky thing of the day. I'm going to do a live demo. Yeah, we wanted that, yeah? You know, it's always the same in IT. You do the live demo at home 20 times, it works perfectly, and on the day, yeah? But this time we're going to try to see things how they work. So what I have, thanks to the organization here, very efficient, I have my laptop connect with a wired connection to start not having too much latency of the millions of tablets and mobile phones connected to the current wireless. And what we're going to do is we're going to have a quick session to look around the interface of the public cloud. We're going to describe a little bit the service and see what is different in that public cloud from HP compared to OpenStack upstream. But what we're going to do as well is we're going to simply deploy a small infrastructure, instances, network. We're going to play with neutral, SDN, and we're going to review a little bit of the services through it. So it's only a half hour. It's a bit of a push-push demo, but I hope you can see and everybody can see what's happening. So the first page where I am here is on hpcloud.com. When you go there, you register, you sign up, and then you say sign in into the console, and you arrive here. So this is obviously the first authentication page. You enter your password and user, and you log in. Oh, wow. I got to say bravo for the wireless connection here. So effectively, first I arrive into this page, which has a fair bit of things. But what it does, compared to an upstream Horizon again, this will describe all the services we currently have. On this page, you actually activate services, and you go into a specific interface to deal with it. So as you can see, the public cloud of HP is currently established on the East Coast, US East, that is actually in Reston, Virginia, in our data center. And the West Coast is actually in Las Vegas, right? So we have effectively East and West. When you use the public cloud from EMEA, from Europe, I always recommend to use East, obviously for latency reason. You can as well use West. But you're going to look at latency, obviously, tapping into a cloud infrastructure of about 200, 300 milliseconds. So usually this works well for web application, but if your application is really, down to that, think about that. So when we arrive here, I can see in US East, I have a few services, compute, monitoring, object storage. In US West as well, I have as well relational database, Trove from OpenStack, available in West. And I have DNS as a service, as global services. What you can see as well on top is the name of my project. So we're going to go into my Boris UAT project. And we can see, obviously, on top as well the zone. And as I say, for latency reason, we're going to use US East. So once we're there, we're going to go effectively into our compute area, compute instance. And this is where what we're going to see here is a little bit more familiar for the one of you who know Horizon, who know the normal, obviously, framework and web UI of OpenStack, the dashboard. So once I'm here, what I can see? The first thing I can see, I have first identity, project, network, object store, and metering. Metering, obviously, is a part that I mentioned before that HP has added in order to provide cloud services right now, public services, and for you to be able to be charged. So we talk a lot about pay-per-use. We talk a lot about pay-as-you-go. That system is actually pay-in-arrears. And there's a big difference between the two. Pay-as-you-go usually requires you to put a credit, and then you consume that credit, right? Pay-in-arrear means you start basically by paying nothing. And 30 days later, you receive an exact itemized bill for everything that you use, right? The lowest denominator for compute is per hour. So that means if you're going to use an hour and 10 minutes of compute, you will be charged 2 hours, right? And the minimum denominator for storage is per gigabyte per month. So of course, we're going to take a pro rata usage. So if you use 1 gigabyte from 1 day of the month, we're going to divide that cost by 30, obviously. Right? So it's completely itemized, and it's completely pay-per-use. So once I'm here, I see effectively in compute I have an overview. My overview is going to give me a vision onto my quota. This is, as a user, what I can do currently. So I can see I have an instance of 40 instances. I have unlimited vCPU. Thank you, HP. I have 200 gig of RAM available. I have floating IP, 45, and I have a security group as well. One point on the floating IP, something that is very particular of HP Public Cloud, is HP, luckily enough, is the only company on the planet that has 2 Class A IPv4. we have 15 dot and 16 dot. So we're lucky because we have a lot of IPv4. And because of that, when you're going to allocate a public IP onto your workload in a public cloud, we will give you a 15 dot. So that means that is a stable, fixed and routable address to your workload. So that is interesting because you will find in a lot of public services you have a lease, and that IP tends to be renewed. That IP tends to be renewed. There we give you something that is routable in Class A directly. So once I've seen this, instance, we've seen that, volume is seen there, images are the images available, obviously, access and security is a place when you're going to do security group, key logins, etc., right? So what we're going to do first is we're going to look at the network, and we're going to look at the network topology. So what I did as training a little bit, you've seen that picture before in the presentation today, but then you're seeing it live. And what I did is I created effectively two networks. So we have first, on the left, the external net. This is your gateway to the internet, gateway to external services. In the middle, I create a network that I've actually called UAT, User Acceptance Testing. I create another one that I call PROD, Production Network. As you can see here, I can see my IP address range. This is on the 10.0.1/24. This is 192.168.1.124. And essentially, this is SDN. This is software-defined networking. I'm creating subnet and network. I'm assigning exactly the IP range that I want to them, and then I connect them to the router, which is in turn connected externally to my gateway. So what is interesting there is just with a browser, with no other infrastructure, I've already reproduced a dual network infrastructure. So to show you how we do this, what I'm going to do now is to create an additional network. So I come to that wizard. I'm going to call this one Devil, as this will be my development network. I'm going to click Next. Now, of course, I'm going to give it a subname for my subnet. And then I'm going to pick an IP address range, right? So, for example, we're going to take 192.168.5.0/24. I can choose IPv4 or IPv6. Who use IPv6 here? Be courageous. Oh, wow. Bravo. Remember, IPv4 is running out, or supposedly it is. And then, of course, I can do additional things in that network. I could set a specific gateway IP if I wanted. I could disable the gateway too. And additionally, what I could do as well is to create, of course, I could remove the HTTP. I can have over allocation pool. I can have a specific DNS server, and I can have a specific route for that particular network. In this case, I'm going to leave things exactly as they are, just by default. So what is happening now is now we have Bang. Another network has just been created into the IP range, and that network, what is it missing now? If you look at it, it's been moved. The new network we create is in orange. But as you can see, that network doesn't have a connection to the router. So the orange network there cannot get out. So to do this, I'm going to need to add an interface to that network. So what I do this is by going to my routers, clicking the router itself, and then saying add interface. And when I'm going to add an interface, I'm going to have all the subnet that I created, and as we know, we just created the Devil one, so we're doing add interface. And obviously, what we just did now is we connected that network to the router. If we come back to the topology, we can see now the orange network is now back into the router. So now I have 3 separate networks, 3 IP address range, all connected to the router with an external gateway to the net, right? And all this, again, is solved SDN. There's not a real router. The router is just an object in OpenStack. So are the network. Everything is built on neutral. So now that I've done that, I'm going to go into my compute area, and we're going to review access and security. So if you're not familiar with OpenStack, OpenStack has a model where every single instance you launch will be firewalled by default. You need to create a security group. That security group is an object in OpenStack that has specific firewall rule, egress, ingress, specific service, whatever you want. And then you launch the instance in the context of that security group, and then obviously those ports will then be allowed for connection. Right? It's very important to remember that because of all the FUD around cloud, oh my God, security is dangerous, etc., we decided to take that approach, and OpenStack has taken that approach, copied from AWS, by all means, to effectively firewall everything until you say so. So it's really diminutive until you actually declare the interface that you want. The same for connection to the machine, would it be Windows or Linux. You could have a password-based authentication, but again, as we know, not really secure. So what we're doing there is effectively first security group. So let me show you the security group that we have. We have one, a single one called default, and we're going to look at the rules that are currently into that firewall group. So what do we have? We have egress, IPv4, IPv6, most notable 22 SSH for my Linux connection, and of course 3389 RDP for my Windows connection, remote desktop protocol. So that security group essentially let all machines connect to the outside, avoid any connection coming from the inside, and only open 22 and 3389 on TCP. Clear? So that security group is done. Now I'm going to go effectively going back to access and security. I'm going to go into my keys. And effectively, I have key pairs. So that key pair, what it is, it's an asymmetrical crypto key that is created by the platform. You could as well, if you look on top, the import key pair, you could import your own key. So if you're already living in infrastructure with SSH key distributed, you could actually validate that directly in a public cloud. You don't have to generate one. In this case, I've generated one that I call test. I can see its fingerprint. And when you create that, the public part of the key will be downloaded on your machine, and the private part will be injected in the instance when you launch. And of course, then you have an SSH key exchange on the login, and if the key match, obviously, you will be let in. So that's a very secure way, by using SSH keys, to actually connect. So this is what's enforced by default. So once I'm done with security, I'm going to go back now to my instances. And as you can see, I'm running absolutely 0 instance at the moment. So what I'm going to do is I'm going to launch instances. 1, 2, 3, 5. Again, the beauty of the cloud. It takes the same time to launch 1, or to launch 10, or to launch 100, because it's API, of course, related and requested a load network. So another thing that's important in a public cloud right now, you have 3 types of images that are available in a public cloud. The first one are the vendor images. So that will be the classic Linux, the classic Windows, and these will be patched, right, by the vendor. So we recycle them every 3 months. You have a new version that integrates all the latest patch that is vendor provided. The second part of images we have in the public cloud are appliances, software appliances. So we have a large network of partners. You can find out by going to marketplace.hpcloud.com. And all those partners provide effectively software appliances that you can actually deploy directly from the cloud. So instead of having to configure the whole machine yourself, some product like security, etc., will be available. Very nice. See, there's a live demo. Suspense. Try again later. Trying now. Nobody is downloading a movie on my... Oh, here we go. So now that I have this, I have a launch instance that's a much more complex panel, so we're going to go through it. The first thing that he offers me is to pick which availability zone I want to launch the instance with. So our implementation in the public cloud, we have US East, US West, and then 3 AZ within those 2 regions. And the concept of availability zone in OpenStack is a logical or physical separation, segregation of your infrastructure. It's entirely up to you. So an availability zone could describe maybe a production area and another one a testing area, or they could be actually geographically separated. If you have a cloud in New York, one in Singapore, one in Amsterdam, you have 3 different zones for them, right? So this gives me an option to say in which zone would you like that instance to be launched. I can pick, or I can say any. So if I say any, I let the public cloud deal with its own business and know where it's better to launch the instance for me. Now, if I go to the instance name, we're going to take a very original name here, testing. This is just a namespace for your instance, right? It has nothing to do with DNS at this stage. It's only a reference within OpenStack. Then I'm going to choose the flavor. So we do a fair bit of flavor on the public cloud. The biggest one is our standard X8XL, which, as you can see on the right, will give me 16 vCPU, 30 gig of root disk, 128 gig of RAM, and obviously I can see on my project limit, on my quota, if I launch one instance, what this represents, right? So now what I have just underneath there is the number of instances I want to launch. So if I say 1, obviously, if I say 10, bang, you can see that I'm completely outside of my quota. So I could actually, play a little bit and launch 100 million instances, which I think I'll receive a phone call in a minute, so we're not going to do this. But instead, what we're going to do is we're going to look by the numbers, and we're going to take first a smaller flavor. We're going to take something like just a standard small, which is 2 CPU, 2 gig of RAM, as we can see. And now we're going to say, let's launch 12 instances, right? So what is it going to do? It's going to launch 12 of the same instances, deploy them with the security group with all that I'm specifying. So the next thing now is to choose, well, what do I want to launch? As you can see, OpenStack is very flexible there. I can launch from an image. That image will be simply stored in OpenStack, downloaded from Glance, executed on the local KVM hypervisor. I could as well launch from a snapshot. What is a snapshot? Well, a snapshot is when I'm running an image and I want to actually save it, fix it. I have the ability to take a snapshot of a running machine to keep it in that state. So I could relaunch that state. This is very important, the snapshot facility, particularly for continuous integration work. If you have several people working on the same project, you're going to be able to carry on and to fix effectively a state and always come back to that state and relaunch multiple machines in that state. So snapshot is very, very important. Don't consider snapshot as backup, though. That is a mistake in your strategy if you do. They are two different things, right? But that ability to continue and to leave that machine in a particular state and to carry on and to have then several snapshots later on, I mean, that's exactly what continuous integration and things like automating testing and etc. will do for you. So let's say we're going to boot from an image here. And now, which image do I want to launch? As I mentioned before, 3 types of images. Vendor Linux, vendor Windows, partner Linux, partner Windows, and then obviously private images. So I have the ability to push my own images to the public cloud. Once they push, they're available only to my login, only to my tenant. And obviously the great advantage is I'm going to be able to reuse existing image that I already have in my enterprise. One of the previous presentations, a lot of people have mentioned, do I move my workload? Don't forget that Glance and OpenStack with KVM support actually most of the image formats that you have on the market. VHD, VDI, AMI, ISO, anything you want to throw it. Raw images. OpenStack will actually just store it and we launch it on the hypervisor. VMDK from VMware is a bit different. You need a little manipulation. You will need to insert what we call the Vert IO driver inside it. But once you've done that, pretty much every single image format is understood and run on OpenStack. So there's minor conversion to be done to move your images if you choose to push your private images there. And again, a lot of people are asking us about orchestration, or do I start from scratch to reproduce what I do inside? Well, don't. Take your current qualified image that you're running in enterprise workload, push that to the cloud, launch that. It may not be perfect, but that's already put you 3/4 of the way there. Then you can actually do the changes that you need to simplify that workload. But that's effectively one of the unique advantages of OpenStack is to be able to read many image formats and allowing you to push you on. So here we're going to take something easy. We're going to take CentOS 6.3, for example. And once we've done that, we go to the next tab. And the next tab is access and security. So that's where I specify the key pair, you remember, that I created, that is to be injected in my instances, and where I pick my security group. So I made things simple here. I create one security group with all the rules, but security groups are just objects. So you could create as many as you want. And you could have one rule per object, and then you can have some policy or launching instance with many security groups. They will all add up, and will all be concatenated into the same security policy. So it's interesting because you have that flexibility. You can either put everything together, or then you can classify each security group and attach them to a particular instance. Further down the line, in OpenStack, you'll be able to match that to users too. So users and group will then be secluded into zone, into availability zone, with certain image and certain workload. So that gives you a perfect delegation system in the enterprise. So once I've done that, I'm going to go to networking, and that is the most interesting of all. And what I can see now, my free network that I created, you remember. So now I'm going to pick which network those instances are going to live in. And for the purpose of this demo, we're going to add this one. I can see it become NIC number 1. I'm going to add this one. It becomes NIC number 2. And I'm going to add this one, NIC number 3. So essentially, I'm launching now 12 instances with 3 NIC each into each of the network that I define. But yet, those machines are not yet exposed externally. Does that make sense? Those machines will launch with having 1 NIC into each network, and then to expose them externally, I will pick the particular instance and then attach a floating IP to that instance. Then that instance becomes reachable externally. Make sense? Too fast? Too slow? Perfect. Okay, good. So once I've done that, post-creation. Post-creation is a customizable field. If you want to know technically where does that come from Amazon. Amazon has something called EC2 user data, which is a user environment variable that you can push to an instance with a single script, a single line, 254 character, and this will be executed once every time the instance launch. So in 254 character, unfortunately, you can't put that much. But the whole trick there, with a work that's been done in the past by other company, which is called Cloud Init, what we do is we encode that single line in MIME. And because it's in MIME, when it gets decrypted, you can actually put a whole book in there if you want, right? So the big trick of this is now I can put a full customizable script. It doesn't have to be bash. It has to be any interpreter that is installed on the machine. So if I do bin Python and I have Python on the machine, it will work, obviously, right? And then that can be a customizable script that I put per instance that will launch. In this case, I'm not going to do any of that. I'm going to leave it as it is, and now we're going to go for launch. So what is happening now in the way of OpenStack? I authenticated to Keystone. Now I'm speaking to Nova API with a single request to say essentially launch me 12 small CentOS instances with 3 network each, right? So Nova API speaks to Nova, now the head of the hypervisor, say, hey, who has space for 12 machines? So it makes an election to find out effectively where that space is. When he finds it, bang, see? Delivery cloud, instantly. So right now what's happening, he found it. Those machines are going to refresh until they're spawning, launching, spawning, launching. You can see the different LZ. This is interesting. I've never seen that before. It's a bit of a flash happening here. We'll come and refresh that in a second. In the meantime, we can go to network and go to network topology and find out how things have evolved here. A bit of refresh. So obviously that's a bit of a workload. We're launching 12 machines at once. Bang, and here we are. So as you can see, my instances are here. They haven't yet connected to the third network. You can see the slash bar telling me that they're actually currently launching at the moment through my representation. But when this is done, effectively, I have now 12 machines with 1 NIC in each network, and then I can assign which one I want to reach externally or not. So this is particularly good when you're going to look at 3 tiers infrastructure. Yeah? Anything with server, presentation layer, database behind, you're going to be exposed to put those into specific network without exposing any of those services. And this is not, I mean, in Amazon, you don't have that choice. In Amazon, you launch an instance, you get exposed immediately. Immediately, you get assigned an IP because that's the only way to connect to it, right? Where here, you have effectively the ability to make those services interconnect between each other within the secluded SDN network and then expose only the necessary service you need for consumption. As best practice, all your free-tiered applications should be communicated on the SDN network, and only the service, the consumption of the service itself of the application should happen externally. It is very bad practice to make your application connect and speak on the external net at the same time, obviously, right? So now that we've done that, it looks like we're okay. Can I ask a question? Not yet, but thank you. It's a dictatorship at the moment, you notice? Sorry, I'll have a question, obviously, yeah. But I just want to make sure, okay, here we are. So now what we can see all our instances. You can see the instance name has been added a dash with a number from 1 to 12. Obviously, I launched 12 at once, yeah. I can see effectively the OS I'm running. I can see now my free IP address per machine, as you can see. And they're all obviously through the HTTP. I can see the size. I can see the name of the key pair that I used to connect to it. I can see my availability zone, the status. The task, known at the moment, is running along and tags. Tags are an important feature as well, because that interface looks lovely with 12 machines. If I now launch 100,000, believe me, you don't want to look to see what 100,000 line looks like in a web interface. It looks ugly. This is why you use API and command line to manage such large environment. So this will show me that, and then what I can see on the right is all the function and all the things that I can do with my machine. So as I can see, as I mentioned before, I could create a snapshot immediately that will store exactly that instance in this state and available for me to relaunch as a snapshot. But I can do a vast number of other things here. So I can associate a floating IP, which I explained is the next step to expose that instance externally. I could effectively disable the IP. I could edit the instance, edit the security group, view the console, view the log, soft reboot, hard reboot, power off, terminate, set a tag, or rebuild. Right? So lots of functionality there is available. So if we were to see view log, for example, technically what's happening there is a trick we exposing every Linux machine, we making not only speak to the local console, but it speaks over to a serial port. And basically, we scrap the serial port at boot. That's the reason why we can see a log. There is no introspection. We cannot see what's happening inside the VM, but we can effectively harvest the log. So as you can see, this is a typical Linux boot log. OK. The most important part, starting cloud init configuration with the insertion of the key, as you can see. So if you have that, you know your instance has boot properly, you know the SSH key has been properly inserted, and therefore you can connect to it. So that's a good way to backtrack it. We're going to do something dangerous. We're going to try to access the console. Can't guarantee anything at this stage. But this should give me 1, 2, 3. Oh, we like that, don't we? So now I have, of course, a full access console, and I can log into my servers, and obviously not recommended. This is over encrypted VNC, so don't expect such a stability over it. But effectively, that's available as so. So this gives me, this is basically the overview that I wanted to give you. I'm looking at time, how we're doing. And obviously, sir, thank you very much for being patient. I'm now ready to answer your question.
I was wondering if traditionally you would also have a management network. And is the typically out-of-band management network that's not in the picture, but it's always there?
Well, so in a private cloud, absolutely. This is a public cloud. The ultimate administrator to this is HP. Not me, right? On there, I'm just a user. So to answer your question, of course, there's a management network behind it for us to have access to all of it, right? But that's not, of course, that's not exposed to you. But in terms of you deploying an application, you could as well create one of those SDN networks as being your management network entirely. Absolutely no problem. Again, this is infrastructure as a service, so you're absolutely free to implement anything you want. You're launching OSs, base operating system, networks. You could add root. You could remove the HCP. You could do pretty much anything you want. You could restrict the network as well. Does that answer your question?
Now, I was wondering, since you can already log into the server, there is a way to communicate to it via a network that's obviously not in this picture.
Oh, OK. So sorry. Yeah, very good question. So how can I connect to my... I'm going to change the question by saying, how can I connect to my network without exposing the service forcibly? Yeah, do I have a way to get into the network without going through the public phase? Yeah, is that...
You could log into one of the servers.
Yes, of course.
But yet you didn't give it an IP address yet.
Absolutely. So right now, I can't log into those servers because they're not exposed externally. Yeah. Right? Well, I can log into the console internally, but that's all I can do. Right? If I want to connect TCP IP externally to that, I'm going to have to expose it externally. Right? However, what you can do in a public cloud, and what a lot of people do, is they launch one instance, and on that instance, they install OpenVPN. Then, of course, they create a VPN gateway in a public cloud, and then they address that through that network, and then, of course, expose the rest of the services they want. So again, think of it as being inventive. This is infrastructure as a service. You can pretty much build everything you want. Please.
So you made a router in there. Can you also set firewall policies between those VMs?
So I can set firewall policies between those VMs, but all this will work by the security group implementation that I showed you. Right? So let me actually demonstrate that to make more sense. So if I create a security group, in there, they're very classic. They all allow everything from 000 CIDR to make it simple. But I could, of course, restrict certain firewall to certain source address. So therefore, I could say, hey, all the VM on that range can't connect. Do you understand where I'm getting at? So just to show you if this is possible, if I go into a security group, I'm nearly done, sir. If I go in security group, say manage rule, and if I say add a rule, then I'm going to have that. So I have already, obviously, fully pre-selected services, a bit like on your wireless router at home, yeah, when you want to expose a port. But then, as you can see, what I can do, I can choose remote, and it could even be another security group. Do you understand what I mean? So I can say all instances in that security group can have access. Does that make sense? So it's possible to make some very complex policy, effectively, of access between networks, but you don't do it at the network level. You don't do it like if it was a firewall in a traditional infrastructure. You do it within the security group. Does that answer your question? Thank you. So unfortunately, I've been told I'm done, so thank you.